Hello everyone, this is lecture 20, Lebnitz theorem. Now, the Lebnitz theorem. This theorem is applicable for finding the nth order derivative of the product of two differentiable functions. Suppose we have two functions u and v, we are two functions of x such that their nth derivative is exists, that is the nth derivative of u and nth derivative of v is exists. Then the nth derivative of product of these two functions, that is u into v, is what? So the nth derivative of u into v, here you have to remember u and v is what? They are two different functions. So the expansion by the Leibniz is what? Is nc0 nth derivative of u and the second function v is same plus nc1 the nth derivative n minus 1 time derivative of u and 1 time derivative of v plus nc2 the n minus 1 n minus 2 time derivative of u function and 2 time derivative of v function, and so on. The last term is ncn u function as it is and the n time derivative of v. Or simplify, we can write that nc0 is what? Is in, nc0 means combination, c represent the combination, and this dn of u means the nth derivative of u, so we can write u suffix n into v plus nc1 n minus 1 time derivative of u, you can write u n minus 1. We just write the suffix n minus 1. It means this is what? This is the nth n minus 1 time derivative of u into 1 time of v, derivative of 1 time of v, so we write v1 plus nc2 u n minus 2 and 2 time derivative of v, so we write v2. Here v2 means the 2 time derivative and u n minus 2 means n minus 2 time derivative of u, and so on. And the last term, that is nth term, is what? ncn u and v n minus 1. So here you have to note that. Now take an example how to use the Leibniz theorem. So if suppose we have given x is equal to 10 log y, then we have to show that equation. This is what? 1 plus x square y n plus 2 plus 2n plus 1 into x minus 1 y n plus 1 plus n n plus 1 y n. Here you have to note that y n plus 1 y n and y n plus 2, it represents the, and that yn means the nth derivative of y, and that yn plus suffix yn plus 1 is means the n plus 1 time derivative of y, and similarly that yn plus 2 means the nth n plus 2 time derivative of y. So here first we write the given function, that is x is equal to 10 log y, but you see we have to prove that equation. In that equation we see the y represent the dependent variable and x represent the independent variable, so we convert that into the term of y. So we can write, take that 10 in that side, we write the 10 inverse, and log y is equal to 10 inverse, so we can write y is equal to e power 10 inverse x. Now just we take, that is equation 1. So now differentiating equation 1 both side with respect to x, so what we get? So here we write that the derivative of y, we write y1 is equal to, and the derivative of e 10 inverse x is what? E tan inverse x into the derivative of tan inverse x is 1 upon 1 plus x square. Or now that e की power tan inverse x is what? From equation 1 it is y. So we can write this implies y1 is equal to, we write that is y and upon 1 plus x square. So or we can write that equation y1 1 plus x square y. Now take this is equation 2. So here you see that y1 means the derivative of y, one time derivative, and if we operate the nth derivative on that equation, so you can be imagine the term y1 become yn plus 1, but we required yn plus 2. So differentiating that equation 2 again, differentiating equation 2 with respect to x, so what we get, apply first function same, that is y1 1 plus 2x, we get differentiation 2x plus now the second function 1 plus x square, and y1 derivative of y1 it become y2 is equal to that the derivative of y is what, y1. Now simplify that equation, we can write 2x minus 1 y1 plus 1 plus x square y2 is equal to 0. Now differentiating n time of equation 2, suppose we say this is equation 2 by Lebnitz theorem. So apply the n time derivative on equation 2. So we write the n time derivative of 2x minus 1 y1 and n time derivative of 1 plus x square y2 is equal to 0. Now we have to take the nth derivative of that on that function. Here you see there this is a product of two functions, 2x minus 1 into y1, and similarly this one is also product of two function, we can say 1 plus x square into y2. So here when you apply the Leibniz theorem, take the n derivative of that function, so you take the first function that is u and v that is 2x minus 1. So you have to remember when you take v that is a second function, so you take that function which is reducible after differentiation. So here you see the 2x minus 1, we take the first derivative we get 2 and the second derivative of that function is 0. So you take this is v and this y1 you just consider u, and in the second here you consider that is v and that y2 you consider is u. Now we can rearrange and write them, that is y1 into 2x minus 1 and n time derivative of y2 1 plus x square. Now apply the Leibniz theorem. So nc0 n time derivative of the first function that is y1 and the second function u is same, that is 2x minus 1 plus nc1, now n minus 1 time derivative of y1 into 1 time derivative of the function 2x minus 1. Now if you write the third term of that series, so you get nc2 n minus 2 time of derivative of y1 and 2 time derivative of that function 2x minus 1, which become 0. So there is no need to write the other terms. Now apply on the second term the nth derivative of that function. So here what we get, nc0 n time derivative of y2 and the second function, that one 1 plus x square is same, plus nc1 n minus 1 time derivative of y2 and 1 time derivative of that function 1 plus x square, plus again you see that 2 time derivative of that function is exists, but the third derivative is 0 of that function, so we write one more term nc2 dn minus 2 y2 and the 2 time derivative of 1 plus x square, and the remaining terms become 0 because in that term we get the d cube of 1 plus x square. Now we just rearrange and write the value after simplification. Now what is nc0? It become 1. This nc0 is 1. We write 1. The nth derivative of y1 function, so you just add that into the suffix of y1, so you write yn plus 1 and into 2x minus, become minus 1 plus, now nc1 is what? nc1 is n into n minus 1 time derivative of y1 is what? Is, just write in the suffix of that, so we write y1 plus n minus 1. So what we get? Write y n minus 1 plus 1. So we get only yn, and 1 time derivative of that is 2 plus all terms are 0 remaining. For this nc0 is again 1. The n time derivative of y2 we write yn plus 2. Just add the power and the suffix of that y1 y2 and 1 plus x square plus, now in that term nc1 is n and the n minus 1 time derivative of y2 it become, you just add this power of d in the suffix of y, so we write y n minus 1 plus 2. What we get? Y n plus 1 into 1 time derivative we get 1 plus x square, we get 2x. Now in the second term nc1 is what? n minus 1 upon factorial 2 and the n minus 2 time derivative of y2 you add, when you add that power in the suffix you write y2 plus n minus 2, so we write y n and the 2 time derivative of the function 1 plus x square it become 2. Now you just simplify it, this term is cancelled. Now so first you write the highest order derivative, that is yn plus 2, so we write yn plus 2. This is only single term, so we write 1 plus x square. Now we take the common yn plus 1, so we have yn plus 1 and we have 2x minus 1. The second term is there, here you write 2nx plus 2nx, okay, plus, now take yn is common in the term where exists yn, so yn is there, write 2n, right, and there is one more term, this one, so you write n minus 1. Okay, now after simplify that term we have to prove this term. This is what the required equation which we have to prove. You can simplify, you obtain the result. Thank you, and the further topic we discuss in the next lectures.